Hello again. Since you have seen me last, I moved inside to get away from my neighbor as he mows, but then I was called away as I made the video because my wife couldn't get on the internet. So I got her on the internet, did some other grandparental duties, and now I'm back again, slightly distracted. I apologize. All right, we're going to go back to this last problem. It's a tougher problem than the ones we've had before. We're given a linked list, and then we're giving an integer k. And what we want to do is we want to take each group of k nodes and reverse them in the list. So it's similar to the problem we saw before, it just has this extra wrinkle in it. Fortunately, we've already written some code to process lists just like this earlier. So let's start with that. And actually, let's get ourselves a better example than the one they have here, because that example is a little too small, I think. So first off, let's just take a look. I've ripped out the old code and added the new code in here, although we won't implement it yet. And then, okay, so now what we're going to do is we're going to call, so we need to get, we're going to read in the nodes of a list, and we need to read in a value k. Let's have that value k be the first thing we read in. So we'll say cin k. Let's get ourselves k. And then we're going to go ahead and call this procedure. Instead of reverse list, we'll call reverse k group. Okay, and we'll call it on the list and the value k. And then we'll go ahead and print everything out. Okay, now as before, we could actually put everything in a vector and just solve it that way, but then we wouldn't be using recursion, and I'd be denying you the fun of that. So we need to figure out how to solve this recursively. So let's do an example, and I'll write it right up here. So the example we'll do is let's do the numbers 1 through 8. Okay, so it'll be 1, 2, 3, 4, 5, 6, 7, 8. I'd like to have some spaces, so here, let's put some spaces in there. Okay, and let's have k equal 3. So we'll have that be the list, and we'll have k equal 3. So what we're going to do is we're going to reverse the 3, the 2, and the 1, so it'll be 3, 2, 1. And then we're going to reverse the 4, 5, and 6, so that'll be 6, 5, 4. And then the 7 and 8 we're going to do nothing with because there aren't 3 of them. So that one just holds. Okay, so it would be 7, 8, and that's what our return value would be. Now the way we're going to solve this is we're going to basically carve each list into two lists. So when we get it, and we're going to have the head of the list be pointing to this node, and I'll denote that by here, I'll just call it H. What we're going to do is we're going to have, I'll call this R, for the rest of the list, that's going to be k nodes after H. And then we're going to solve it recursively on R. Okay, so we'll recursively solve this on R. So we'll end up with, basically we're going to end up with H being 1, 2, 3, and then after we recursively solve it, we're going to have, we'll set it to RV. RV is going to equal 6, 5, 4, 7, 8, because we've recursively solved it. Okay, and now all we need to do, or here's what I would do, now all we need to do is let's go ahead and null terminate this list and then reverse it, just like we reversed the list in that previous problem, and then attach these two lists together, and we're done. Seems reasonable. Sorry, I'm thinking. I'm not going to think. We're just going to go ahead and solve it. Okay, as I think through this, what that means is we're going to have two recursive solutions. Right, we're going to have the recursive solution here, which solves the rest of the list, and then we're also going to reverse this first part of the list using the same recursive thing we did before. In fact, let's just rip off that code. Nah, that's cheating. We'll write it. Okay, so let's go in here. We're going to have, here, I'm not going to call that head. Let's just call that H to match what we had before. And we're going to have list node RV for our return value, list node R, that'll be the rest of the list. We're going to need an int. We'll have an int I, because we're going to need that to count. And then we're going to need some other stuff, but let's get to that later. Okay, so the first thing we do is let's go ahead and find let's isolate the first k nodes. Okay, so let's say I equals 0 for r equals h. Actually, no, let's stop. Let's get a base case. Let's first count, and if we have fewer than k nodes, then we're just going to return the list because we don't want to do anything with it. So that's fine. For I equals 0, r equals h, I is less than k, and r does not equal null pointer. And then we're going to say r equals r next, and we'll say I plus plus. All right, so that's going to have us count. Oh, God. This code's terrible. Let's do this again. I is less than k. Yeah. Sorry, this is what you get when I haven't prepared anything. All right, we're going to set r equal to h. We'll say for I equals 0, I is less than k, I plus plus. If r equals null pointer, or r next equals null pointer. No, that's not going to work. Let's just say if r equals null pointer, then we're going to return h. And if that doesn't work, now we'll set r equal to r next. Okay, how does that feel? Because what that's going to do is we're going to keep traversing, but if we ever get to a point where we end the list before k elements, it will return it. Okay, so otherwise, let's return null pointer, and let's test this code. All right, so how do we going to test the code? Well, let's test it by giving it a k in a list, and then just test to see if the list is bigger or smaller than k, and see what happens. So, redefinition of solution. Oh, okay. Oh, I'm writing some sloppy code. Oh, no open brace. Okay. All right, so if let's set k equal to 5, and let's have our list be 6 long, and that should return null pointer, so that should print nothing. Awesome. Now let's set that, make it 4 nodes. That should return the list itself. Good. If it's 5, if it's 5, it returns nothing. Perfect. Okay, so this code's working just fine. Okay, so there's our first base case. So now when we get to here, we know the list has at least k elements in it, and that r is pointing to the kth node on the list. So now we can solve this for r. So we can say rv equals reverse k group r. Okay, so for example, if our list is 1, 2, 3, 4, 5, 6, 7, 8, when we call this the first time, right, here's where, and k equals 3, first time r is going to be here. And then after we make the recursive call, we're going to have rv equaling 6, 5, 4, and then 7, 8. Okay. So that does our recursive solution. Now what we need to do is we need to reverse these nodes and then stitch them together. Okay. So to do that, now the nice thing is that we know that this is exactly k elements long. So while we're at it, should we keep track of the previous node? No, I'm just going to be lazy. All right, let's go ahead and do this again now. Only now we're going to go to k minus 1 instead of k. I said this is shitty code. We don't have to test that. Let's set r equal to h. Okay, so when we're done with this loop now, R should be pointing to the very last thing. Okay. Why am I doing this? Because I want to null terminate that node. So now I can say R next equals null pointer. Okay. And now my list is terminated, so now all I need to do is just reverse that list. And I can call a recursive reverse routine on that. So I'll say, let's call it new H. Okay, we'll say new H equals reverse H. Okay, so now we have a reversed list. The original head is now going to be the last node on that list, so now we can set its next pointer to RV, and we're done. So we can say HRV next equals RV and return new H, and we're done. Okay, so you see the steps? We detach this list, call the routine recursively on it. We null terminate this list, reverse it, and then when it's reversed, the old head will be at the end, so we can set its next field to the new list, and we're done. So the only thing we need to do now is write a reverser. So let's go ahead and do that. That one, nothing. And we wrote this code back before my neighbor started mowing his lawn. So that one's easy. Base case if H equals null pointer or H next equals null pointer, then the list is either one or two elements. It's already reversed, so we just return it. Otherwise, list node sn. Otherwise, we're going to set the second node to be the second node. We will get ourselves a return value, call it recursively on the second node. So reverse on second node. And now we're going to hook the first node as the in the next field of the second node. So we can say sn next equals h, and we've got our null terminate h. H next equals null pointer. Okay, and then we can return RV, which should be the reverse list. We reverse it. That will be the end of it. Oh, we're all good. I'm going to test it. Think it'll compile? No. Oh, nice. Have all this stuff up here, not in a comment. To viewer. Oh. All right. I've just fixed so many things. Do you think the probability of this working is anything greater than 0? Here we go. Let's do a nice easy base case. So we'll have k equals 3, and we'll have our list be just 2 nodes. So we should just get the list back. And we do. Oh, back to a.out. All right, that worked fine. Now let's have a leap of faith. Now this should just reverse the whole list. Ooh, that looks good. Now let's add a node to it, and that should reverse the first 3 and give us the last. Oh, this is looking good. All right, 5, 6, 4, 5, 6. Now we should do reverse the first 3 and the second 3. Oh man, I feel like we should submit. All right, feels good. Let's submit. There we go. Watch it not compile. All right, it's compiling. I'm just telling you right now, I'm only feeling like 93% confident this is going to work. Might be a self-esteem buster. Let's try it. Ah, not only does it work, it's faster than everyone else. Fantastic. Okay, I know I went through that quickly and sketchily, but it's nice because it's showing how to use 2 separate recursive routines in here. Again, one to solve the rest of the problem, the other one to reverse the list. So it's a good exercise. So go through it. Go ahead, you can take my code, and type it in yourself and put some print statements in if you're confused about how these things work. This is a good way to help you understand recursion. All right, have good Thanksgivings. See ya.